Welcome, this is Mrs. Rubright with Advanced Geometry. Today's lesson is 2.1, Use Inductive Reasoning. Describe how to sketch the fourth figure in the pattern, then sketch the fourth figure. So in figure 1, you have how many areas? 2, right? 2. In figure 2, how many? 4. In figure 3, how many? 6. So in figure 4, how many do you think you're going to have? 8. All right, so in addition to it being cut into 8 slices of pizza, what else do you think is going to happen? So here we have it shaded above to the left, shaded above that middle line to the left. So shaded above the middle line all the way, the slice all the way to the left. So we would shade in this slice of pizza. Does that make sense? We're just following the pattern. Describe the pattern in the numbers -7, -21, -63, -189, and write the next 3 numbers in this pattern. So what's going on here? From 7 to 21, what are you doing? You're timesing 3, you're multiplying by 3, and then from 21 to 63, you're multiplying by 3. And then from 63 to 189, you're multiplying by 3. So these are negative to a negative to a negative to a negative. So we're just multiplying by 3 because -7 times +3 is -21 times +3. If you're multiplying by a negative, it's going to alternate between negative and positive, right? It'll alternate. So this, we're just multiplying by 3. So if you think back to middle school, you learned about geometric and arithmetic patterns. You guys remember that when you had the geometric and the arithmetic? Arithmetic meant that the pattern, you're adding a number. You're adding a positive or negative number. Geometric, you're multiplying by a positive or negative number. Or you could be multiplying by a fraction, which is really like division, but we just call it geometric, whether it's multiplying by 2 or multiplying by 1/2, which is essentially dividing by 2. Okay? So anyway, what are the next 3 numbers in this pattern? I know one thing. I know they're negative. What is 189 times 3? What? 567. And next? 1,700 and the last one? One person loudly. 5,103. Perfect. So those are our next 3 in our pattern. So far, so good. All right, so sketch the 5th figure in the pattern in example 1. So I want you guys to try this out on your own with your table partner. Try to figure out what the 5th figure would look like. How many slices of pizza? 10. And we're going to shade the furthest left above that midline. And that's what it should look like. Describe the pattern in the numbers. 5.01, 5.03, 5.05, 5.07. What's the pattern? We're adding what? Plus 2 cents. If you think about money, it makes more sense. So if we're adding 2 cents each time, $5 and a penny, $5.03, $5.05, $5.07, $5.09, $5.11, $5.13. Do you guys see how if you think about money, it makes more sense? Get it? Haha, no one's laughing. Got it. All right, we love me so much. My jokes are just so funny. All right, moving on. So, given 5 collinear points. Collinear, we learned that collinear means what? On the same line. Good job. So 5 points all on the same line. A, B, C, D, and E. 5 points on the same line. Make a conjecture, an educated guess, right? Make a conjecture. You're going to make a conjecture. That's like a guess, right? And, about the number of ways to connect different pairs of points. How many ways can you connect different pairs of points? With your table partner, try this out and see what you get. How many different pairs of points can you come up with? Pause the video, or actually, I'll just give you guys a little bit of time during the video. Just try this out. The easiest way to do things is to draw the picture and actually do it. Otherwise, it makes your brain hurt. I'm going to help you guys out. 1, 2, 3, 4. This already went here. 5, 6, 7. This already went to the last 2. 8, 9. This already went to the last 3. 10. 10. Do you guys see how I did that? You could have A and B, you could have A and C, you could have A and D, you could have A and E. A has been distributed to everything. You could have B and A already together, B and C, B and D, B and E. Then you could have A and B have already been distributed to everything. So you could have CD or CE. And then the only thing left would be DE. Does that make sense? Go one at a time, distribute it to everything. +1, +2, +3, +4. 6 + 4 is that 10 that we got. Make and text a conjecture. So numbers such as 3, 4, and 5 are called consecutive integers. Consecutive integers are like when you count like in a row, you know? So 3, 4, 5, or 21, 22, 23, 101, 102, 103 are consecutive integers. Make and test a conjecture about the sum of any 3 consecutive numbers. So like if I add 3, 4, and 5, they add to 12. Well, what is 12? It is 4 times 3. 10, 11, and 12 add to 33. Well, what is 33? It's 11 times 3. So are you guys seeing what's going on here? It's the middle number times 3, right? The middle number times 3 is the sum of the 3 numbers because these two are going to average to that number. Make sense? So the sum of any 3 consecutive integers is 3 times the second number. That's their conjecture. They're going to test the conjecture, so they're going to use different numbers. They're going to use positives and negatives. Right? What if I did -1, 0, and 1? What if I did -1, -2, -3? What if I did 100, 101, 102? Things like that. So they're going to test it out. Does it always work? Well, yes, it does. So then we know that our conjecture is true. Make and test a conjecture about the sign of the product of any 3 negative numbers. So what is the sign of the product of any 3 negative numbers? Well, let's test it out. So I had a negative times a negative times a negative. A negative times a negative is a positive, and a positive times a negative is a negative. So it will always be negative. And I could do different examples with different numbers, but it should always give me a negative, right? So the sign of the product of 3 negative numbers should always be negative. So they're going to test them out, and we get a negative answer. And I can't come up with any counterexample that would be anything other than negative, so we're going to go with the fact that it's true. A student makes the following conjecture about the sum of 2 numbers. Find a counterexample. A counterexample is an example that proves it wrong, that says, hey, no, I found an example that doesn't work for, therefore it's false. If you can find even just one example that makes it not work, then it's false. It has to be true for every case or it's false. So the sum of two numbers is always greater than the larger number. The sum of two numbers is always greater than the larger number. Can someone come up with an example that proves this wrong? The sum of two numbers is always greater than the larger number. Yes? 0 plus 1 equals 1. Is 1 greater than the larger number? No, it's equal to it. So that's a great conjecture, counterexample that proves this conjecture wrong. How about if I did -3 plus 5? That's going to be 2. Is 2 greater than 5? No. That's another counterexample that proves that this kid's conjecture is just not right. It is false. All right, so that is basically our entire lesson on using inductive reasoning, my bad. Using inductive reasoning. We will be getting into deductive reasoning later on in this chapter. I believe it's 2.2. Anyway, have a great day. Like and subscribe, and we'll see you next time.